Acid-base reactions involve an acid donating or transferring a proton to a base, which is a Bronsted-Lowry definition. And another example is a neutralization reaction, where a strong acid reacts with a strong base to produce a salt and water. Oxidation reduction reactions, or redox reactions, involve the transfer of one or more electrons between chemical species, which is indicated by the changes in oxidation numbers and the half reactions. And here copper is reduced because it gains electrons, and zinc is oxidized because it loses electrons. So in a redox reaction, electrons are transferred from the species that's oxidized to the species that's reduced. And combustion is an important subclass of redox reactions, where a species reacts with oxygen gas. So where you have a hydrocarbon, carbon dioxide and water are the products of complete combustion. Now in a precipitation reaction, ions are mixed in an aqueous solution to produce an insoluble or sparingly soluble ionic compound. And the ions that remain unreacted are the spectator ions, in this case being potassium and nitrate. And we'll look at the main solubility rules later on. Now in a synthesis reaction, elements or simple compounds combine to form a more complex compound. And in a decomposition reaction, a single compound is split into two or more elements or simple compounds, typically in the presence of heat. Oxidation numbers can be assigned to atoms in reactants and products, and it's often an effective way to determine which species is oxidized and which is reduced in a redox reaction. And the oxidation numbers can be determined using the groups in the periodic table. So in general, oxygen has an oxidation state of -2, and hydrogen has an oxidation state of +1. So because this is a neutral compound, and we have 4 oxygens and 3 hydrogens, then the oxidation state of phosphorus is +5. Now in a special case of hydrogen peroxide, hydrogen has an oxidation state of +1, so therefore oxygen can have a different oxidation state than -2. And here in a polyatomic ion, the oxidation state of oxygen is -2. We have 7 oxygens and 2 chromiums, so the oxidation state of chromium is +6. So 12 minus 14 is equal to the charge on this ion. And for molecules with a single type of atom, or a single atom, the oxidation state is 0. And when bonded to a non-metal, hydrogen has an oxidation state of +1, whereas if it's bonded to a metal, it has an oxidation state of -1. So therefore 3 hydrogens and a neutral compound means nitrogen has an oxidation state of -3, and here potassium has an oxidation state of +1. Now in the absence of oxygen, we write the oxidation state of the most electronegative element, being sulfur. And because it's a neutral compound, carbon has an oxidation state of +4 here. And similarly, fluorine has an oxidation state of -1, so magnesium has an oxidation state of +2 in this case. Precipitation reactions involve mixing ions in aqueous solution to produce an insoluble or sparingly soluble ionic compound. And we need to remember the following main solubility rules. So compounds, which are salts, with the following ions are soluble. So those that have ions from the alkali metals or group 1 of the periodic table are soluble, and compounds with the polyatomic ions ammonium or nitrate are soluble. So for example, in this precipitation reaction, we have compounds with the nitrate anion and potassium cation, which are soluble, and then when combined, they form a soluble compound, being potassium nitrate, and an insoluble precipitate, being silver chloride, in accordance with these rules. So here, the potassium and nitrate ions are spectator ions, which do not react to form the precipitate. We should be familiar with the following polyatomic ions, and there's some patterns we can see when we name them. So in this table, if the ion has 4 oxygen atoms, the name ends with an 8 and starts with a per. So here we have perchlorate, permanganate. And if the polyatomic ion has 3 oxygen atoms, then its name ends with an 8. So this is chlorate, nitrate, carbonate, bromate. And the names of the polyatomic ions with 2 oxygen atoms end with ite. So this is chlorite, nitrite, bromite. And where there's 1 oxygen atom, the name begins with hypo and ends with ite. So hypochlorite, hypobromite. And other polyatomic ions to be familiar with that don't follow these types of naming conventions are listed here. So hydroxide, cyanide, and ammonium. And acetate can be written using this formula, which describes how the hydrogen and oxygen atoms are bonded to the carbons, or the molecular formula. So all of these polyatomic ions have single charges, with ammonium being the only one that has a positive charge, and the sulfate ion with the most number of oxygens has a name that ends in 8, followed by sulfite with 3 oxygens. And similarly, dichromate has a 2- charge, and phosphate has a 3- charge.